Now let's do another example. So this time, the denominator of the first expression is x squared plus 9x, and the denominator of the second expression is x. And when you look at these two denominators, you will see they do share a factor. Why? Because if we factor x squared plus 9x, it will be x times x plus 9. So both denominators, they share the factor x. And then we will need to rewrite the denominator into the product of the factors. So x squared plus 9x, we write as x times x plus 9 minus 2 over x. So from this, we can see the least common denominator is x times x plus 9, right? So therefore, we know the second denominator x, it needs a factor of x plus 9. So I multiply the denominator of the second expression by x plus 9. Also, I multiply the numerator by x plus 9. Okay, now since both expression have the same denominator, so when I subtract these two expressions, I can just subtract the numerator and over this common denominator x times x plus 9. So this gives me 6 minus 2x plus 18 over x times x plus 9. So that gives me 6 minus 2x minus 18 over x times x plus 9. So that is negative 2x minus 12 over x times x plus 9. Okay, that's it. Or if you wanna, you can continue to factor out negative 2 from the numerator. So your answer will be negative 2 times x plus 6 over x times x plus 9. Okay, now let's see another example. So over here we have 4 over x squared plus 12x plus 35 plus 3 over x squared plus 8x plus 15. Now, just by looking at these two denominators, we cannot see whether they have common factors, right? So therefore, first we do need to factor each denominator. We need to factor each polynomial. To see what is the common factor between these two polynomials. And we have already introduced how to do this. So when we factor this polynomial, okay, we're looking for these two numbers a and b, such that a times b is equal to this constant 35, and a plus b has to be equal to 12. So the numbers which are satisfying this condition they are 5 and 7. So we can factor this polynomial into x plus 5 times x plus 7. Okay, now let's do the second one. So I'm looking for these two numbers. Therefore, the product is 15, and the sum has to be 8. So these two numbers are 3 and 5. So we can factor this polynomial into x plus 3 times x plus 5. Okay. Now once we finish this, we rewrite both denominator into the factored form. So the first denominator becomes x plus 5 times x plus 7. And the second denominator becomes x plus 3 times x plus 5. Okay, now let's take a look at what is the common factor between these two denominators, which is x plus 5, right? So therefore, the common denominator must contain this common factor. So it must contain x plus 5, right? And then it has to contain the factor each denominator has, the other factors each denominator has. So it has to contain x plus 7 and has to contain x plus 3. Okay, so this is the least common denominator. Okay, so once we found this, to write the denominator of the first expression into the least common denominator, as you can see, it needs a factor of x3, right? So we multiply the numerator and the denominator by x plus 3. And for the second rational expression, the denominator needs a factor of x plus 7. So we multiply the numerator and denominator by x plus 7. Okay. So now when we add these two rational expressions, we can add the numerator directly. And over this common denominator. So we have 4x plus 12 plus 3x plus 21 over x plus 5 times x plus 7 times x plus 3. So the answer is 7x plus 33 over x plus 5 times x plus 7 times x plus 3.